Welcome to Astronomy Daily, the podcast where we bring you the latest from the final frontier. I'm Anna.
And I'm Avery. It's great to be back with you today for another exciting episode filled with groundbreaking space news.
In today's show, we'll be discussing a tiny moon rock that's rewriting lunar history, Blue Origin's upcoming rocket launch, the ongoing Orionid meteor shower, and stunning new images from the James Webb Telescope.
So buckle up, space fans. Let's dive right in.
First up, a story that proves sometimes the smallest things can have the biggest impact. We're talking about a moon rock collected by Apollo 17 astronauts 50 years ago, sample 76535.
That's right, Anna. This tiny rock is challenging our entire understanding of the moon's early history. New computer simulations show it formed deep within the moon's crust and then rose to the surface about 4.25 billion years ago.
And here's the crucial part. It didn't get there through a violent impact, which was the previous assumption. The simulations suggest a much gentler process, like buoyant ascent through the lunar mantle.
This gentle rise implies that the moon's large impact basins, the giant craters we see, might be about 300 million years older than we thought. That's a significant shift in the timeline. The researchers used sophisticated computer modeling that simulates the thermal and chemical evolution of the lunar interior over billions of years.
What's particularly fascinating about the methodology here is how they combined geochemical analysis of the rock sample with advanced computational models. The rock itself contains specific mineral compositions and isotopic signatures that act like a geological clock.
Exactly, Anna. By analyzing the ratios of different elements and isotopes, scientists can determine when and under what conditions the rock formed. Then they feed that data into models that simulate the moon's thermal evolution, including how heat from radioactive decay and early impacts would have affected the lunar interior.
This has huge implications for understanding the early solar system. If the moon's basins are older, it means the period of heavy bombardment, when asteroids and comets were constantly hitting planetary bodies, started earlier and perhaps lasted longer.
And that affects our understanding of when conditions became suitable for life on Earth. The heavy bombardment period would have sterilized the planet's surface repeatedly. Pushing that timeline back means we might need to reconsider when life could have first emerged.
Looking ahead, this research highlights why future lunar missions are so important. NASA's Artemis program and other international missions will be collecting new samples from different regions of the moon, which could confirm or refine these findings.
Particularly samples from the lunar South Pole, which has remained in shadow for billions of years and may preserve ancient materials that could tell us even more about the moon's earliest history and, by extension, Earth's formation.
Exactly. If these basins are older, it means the period of heavy bombardment in the inner solar system happened earlier, too. This could force us to rewrite chapters in textbooks about how planets and moons evolved.
It's amazing what we can still learn from samples brought back half a century ago. It just goes to show the enduring value of the Apollo program.
Shifting gears from ancient history to the very near future, let's talk about launch schedules. Avery, what's the latest with Blue Origin?
Great question, Anna. Blue Origin is gearing up for the second launch of its massive New Glenn rocket, currently targeting a window in mid-October.
This is a big deal because the payload is NASA's Escapade mission, twin small satellites designed to orbit Mars and study its magnetosphere.
That's correct. Escapade stands for Escape and Plasma Acceleration and Dynamics Explorers. These twin spacecraft are part of NASA's Small Innovative Missions for Planetary Exploration program, designed to be cost-effective while delivering significant science.
The science goals are really fascinating. Escapade will study how solar wind interacts with Mars's weak magnetic field and atmosphere. This is crucial for understanding why Mars lost most of its atmosphere and water over time, transforming from a potentially habitable world to the dry planet we see today.
Each spacecraft carries a sophisticated suite of instruments, including magnetometers to measure magnetic fields, plasma analyzers to study charged particles, and electron spectrometers. By working in tandem, they'll create a 3D picture of how solar wind particles are accelerated away from Mars.
Now, let's talk about the New Glenn rocket itself. This is Blue Origin's heavy lift vehicle, standing over 320 feet tall with a 23-foot diameter. It's designed to be partially reusable, with the first stage capable of landing on a sea platform and being flown again.
The first stage is powered by 7 BE-4 engines, the same engines used on United Launch Alliance's Vulcan rocket. These methane-fueled engines represent the next generation of rocket propulsion, offering better performance and reusability compared to traditional kerosene engines.
This launch represents a significant milestone for the commercial space industry. NASA's decision to use New Glenn for such an important science mission shows growing confidence in commercial providers for critical planetary exploration missions beyond just cargo resupply to the International Space Station.
It's part of a broader trend where NASA is leveraging commercial partnerships to reduce costs and accelerate mission timelines. This approach allows the agency to focus its resources on developing the most complex technologies while benefiting from the innovation happening in the private sector.
The fact that NASA chose New Glenn for this mission is a strong vote of confidence in the new rocket system, especially after its successful debut flight earlier this year.
Absolutely. It signals that New Glenn is becoming a reliable workhorse for important scientific missions. We'll be watching that launch closely. Now, for something you can actually see with your own eyes, no telescope required, the annual Orionid meteor shower is about to get underway.
That's right, Avery. It begins on October 2nd and will run through November 12th, with the peak activity expected around October 20th to 23rd.
These shooting stars are bits of debris left behind by the most famous comet of all, Halley's Comet. As Earth plows through this debris trail, the particles burn up in our atmosphere, creating those brilliant streaks of light. The Orionids are particularly special because they come from one of the most studied comets in history.
Halley's Comet has been observed for over 2,000 years, with records dating back to ancient China and Babylon. It returns to the inner solar system every 76 years, and each time it passes close to the sun, it sheds more material that creates these meteor showers.
The science behind meteor showers is fascinating. These particles are typically no larger than grains of sand, but they enter our atmosphere at incredible speeds, up to 148,000 miles per hour for the Orionids. The friction with air molecules heats them to thousands of degrees, causing them to glow.
For optimal viewing, you'll want to give your eyes about 20 to 30 minutes to adjust to the darkness. Avoid looking at your phone or any bright LEDs. The best time is typically between midnight and dawn, when your location is facing the direction of Earth's orbital motion, so you're essentially plowing into the meteor stream.
Another great tip is to use peripheral vision rather than staring directly at the radiant point. Meteors can appear anywhere in the sky, and your peripheral vision is actually more sensitive to detecting faint, fast-moving objects.
The Orionids typically produce about 20 meteors per hour at peak, but they're known for occasional outbursts where rates can double or even triple. They're also famous for producing fireballs, exceptionally bright meteors that can light up the entire sky.
What makes this year particularly good is that the moon will be new on October 22nd, meaning no moonlight will interfere with viewing. This creates ideal dark sky conditions that can make even faint meteors visible.
The Orionids are known for being particularly fast and for sometimes leaving persistent glowing trails. For the best viewing, you'll want to find a dark sky away from city lights.
A pro tip is to look about 40 degrees above the radiant point, which is in the constellation Orion after midnight. And this year, the new moon phase means dark skies, perfect for meteor watching.
So set an alarm, grab a blanket, and enjoy the show. It's one of nature's best free performances. Finally, we have to talk about the James Webb Space Telescope. It's done it again. delivering absolutely breathtaking images. This time, Webb has turned its powerful gaze toward Sagittarius B2, the most massive star-forming cloud in our entire Milky Way galaxy.
Using both its mid-infrared and near-infrared instruments, Webb has pierced through the cosmic dust to reveal young stars and intricate structures in unprecedented detail. The telescope's NIRCam and MIRI instruments work together to capture different aspects of this star-forming region.
The near-infrared camera, or NRCam, is particularly good at detecting the youngest stars that are still embedded in their natal cocoons of gas and dust. Meanwhile, the mid-infrared instrument, MIRI, can see through the dust to reveal the thermal emission from warm material.
Sagittarius B2 is scientifically important because it's located just 390 light-years from the supermassive black hole at the center of our galactic center. This means stars are forming in an environment with extreme gravitational forces, intense radiation, and powerful magnetic fields. Conditions very different from star formation in our local neighborhood.
The region contains massive molecular clouds, with temperatures ranging from extremely cold to incredibly hot. It's also rich in complex organic molecules, including some that are precursors to life as we know it. Understanding star formation here could tell us about the conditions that might lead to habitable planetary systems.
One of the key mysteries astronomers hope to solve is why this region is so efficient at star formation. The current theory involves turbulence and compression from nearby supernova explosions and the gravitational influence of the central black hole, creating ideal conditions for rapid star birth.
Webb's observations will also help scientists understand the initial mass function in extreme environments. That is, the distribution of star sizes that form. Do these harsh conditions favor the formation of more massive stars compared to quieter regions of the galaxy? This research has implications beyond our own galaxy, too. By studying star formation in the galactic center, we can better understand similar processes in other galaxies, particularly those with active galactic nuclei, where star formation occurs under even more extreme conditions.
What's fascinating astronomers is a puzzle. This region produces about 50% of all the stars in the galactic center, yet it contains only about 10% of the material found there.
So it's incredibly efficient. These new images will help scientists understand why. They're studying the physics of how stars are born in this extreme environment, right in the heart of our galaxy.
It's another reminder of Webb's incredible power to unlock secrets of the universe that were previously hidden from view.
And that wraps up today's Cosmic News Rundown. From the moon's ancient past to the birth of new stars, it's been a fascinating journey.
Indeed. Thanks for joining us on Astronomy Daily. Be sure to subscribe so you don't miss our next episode. And please visit our website if you'd like to check more of today's space and astronomy news, along with all our back episodes. Just go to astronomydaily.io.
Until next time, keep looking up. I'm Anna.
And I'm Avery. Clear skies, everyone.